but compasses are for pussies anyway. Real mathematicians use string and pen. Good morning, fellow mathematicians! Welcome back to another video. Once again, it's exam solving time. And yeah, this is now part 2 out of 3 of solving the Mittlere Schulabschlussprüfung of Saxony-Anhalt here in Germany. And if you don't know what I'm talking about, links to the exam review and exam solution playlist will be in the description, pinned comment, and also in the info box up there. We are going to dive right in, and tomorrow there's going to come out the last part number 3 of the solutions. Part 2 now. A train is driving an average of 160 kilometers per hour, meaning we are going to make use of the Dreisatz, namely that 1 hour corresponds to 160 kilometers driven by train, and calculate the time it takes for the train to travel 400 kilometers on average, meaning we are going to deal with a linear function here. This is why this scheme is going to work out. So how long does it take to reach 400 kilometers? Well, what you do now is multiply this together. So this means we got 1 hour times 400 kilometers over what's left here, over 160 kilometers. Okay, you see the kilometers are going to cancel out, which is good because we are looking for time in hours. And now we have 1 times 400 is just 400. So if you have 400 apples, then this is just 1 times 400 apples over 160. And now you can ask yourself the question, because 160 is 2 times 80, how often does the 80 fit into the 400? Well, 5 times, and take 1/2 of this. Okay, 5 over 2 is going to be 2.5 hours. Okay, my weird arithmetic going on in my head. I hope I'm not confusing anyone here. And this corresponds to 150 minutes. Exactly, and thus we are done with the first exercise. Next up, the following picture shows a wheel of fortune partitioned into 5 equally sized regions. The wheel will be spun 2 times, and then the sum of the 2 numbers will be calculated. Calculate the probability of the numbers adding up to 18. Well, how can we compose 18 out of 2 numbers added together here on this wheel? Well, let's just imagine 7 plus 7 is 14, 1 plus 1 is 2, 5 plus 5 is 10, 3 plus 3 is 6. Well, it only works for 9 plus 9. Meaning, if we spin this thing 2 times, it has to show 9 each and every time. And now this really leaves us with a really pathetic tree diagram. So we are going to spin once, and this is 9, and then we are going to spin a second time. This is also 9, and what is the probability of us spinning 9? Well, it's partitioned into 5 equally sized pieces, meaning the probability of spinning a 9 is exactly 1/5. Same probability here, and now we are going to make use of the first Fahrtregel, path rule. I don't know if they are called this in English, but it's 1/5 times 1/5. So the probability of spinning an 18 overall is 1/5 squared, leaving us with 125. So 4% chance to have this happen. Next up, photos can be printed in the formats 9 to 13 and 10 by 15. I'm going to put it like this with the division symbol, just because we are going to go the route of taking a look at the aspect ratios basically. So this is 9 by 13, 10 by 15, then we are going to have 13 by 18, and then we are going to have 20 by 30. And now we need to see which of those formats are actually similar. And yeah, it's probably kind of a hard feat for many students here, but you just have to take a look at the prime factorizations yet again. What we do here is just backwards engineering expanded fractions. So 13 is a prime number, meaning we can cancel out anything. 9 is 3 times 3, so 3 times 3 over 13 is just 9 over 13. Nothing can cancel out here. Same should be here. 13 is a prime number, so 13 over 18 is going to stay how it is. But what about 10 over 15? Well, 10 is exactly, as its prime factorization, 2 times 5, and 15 is 3 times 5. Meaning 5 and 5 is going to cancel out to 2/3. Now what about 20 over 30? Its prime factorization of 20 is 4 times 5, meaning it's 2 times 2 times 5, over, and then we have 30 is 6 times 5 is 2 times 3 times 5. Okay, 5 going to cancel out, 2 is going to cancel out. 2/3 aspect ratios are actually equal, so it's like with the 16:9, okay, 69. Aspect ratio for your TV, for example, those aspect ratios are the same, meaning those are similar in a way, those formats. Next up, we are going to deal with a prism, okay? And just as a side note, from this point onwards, so in this tool assisted part, you can make use of tools like the lookup table or the calculator. So yeah, let us go ahead. Just if you don't know any formula here, you can take a look into your lookup table and then you can get yourself the formula for the area of a triangle, for example. So we have to calculate the surface area of a prism here. I'm going to draw it out and then we are going to talk about it a tiny little bit. So, what is the surface area of this thing? Well, for structures, geometric figures that are made out of polygons, it's pretty easy because they are just all the areas of the polygons added together. Meaning this prism right here consists of 3 rectangles, equally sized rectangles, and then 2 triangles in a way. And now we are going to calculate the area of this rectangle right here. Area of a rectangle, and then we are going to calculate the area of the triangle. Then we are going to take this 3 times, this 2 times, add them together, and then we have the surface area. It's as easy as it is. So at first, let us take a look at the measurements of this prism here. It has a height of 6 centimeters, and each side of this equally sized triangle, so equilateral triangle, I'm terribly sorry, is 3 centimeters. Meaning the area of a rectangle is exactly 18 centimeters squared, centimeters squared, because we have 6 times 3 centimeters. 6 centimeters times 3 centimeters makes centimeters squared. I mean, it's an area, okay, that makes sense, all right. And now, what about the area of the triangle here? So I'm going to give you a really quick derivation. I have kind of derived it before on my MIT exam solution thing, okay? So if we take a look at this equilateral triangle, what we basically do is, so this is 3 centimeters here, and this is 3 centimeters, and so on. What we basically do is we cut this triangle up and put the other half exactly here, leaving us overall with a rectangle. And well, this rectangle is pretty easy to calculate. It's just the half of the side length that we had here. So 3/2 times the height in this triangle times the height is going to be exactly the area of our triangle. Okay, this is good, but what exactly is the height that we are having here in this triangle? It's pretty easy to calculate actually, because what we are getting here is basically a right triangle where we have 3/2. So if this is our length A right here, then this is just half of the length A of this triangle, of the base. Then this is our height, and this is 3 centimeters by definition of an equilateral triangle. Meaning we are going to get by Papa Pythagoras that this is h being equal to the square root of, okay, we are going to get 3 squared, which is 9, minus 3/2 squared is 9/4. Now we are going to expand 9 by 4/4 to bring this onto a common denominator, leaving us with the square root of, okay, what we do is multiply it with 4/4 with a 1 cleverly. 9 times 4 is going to give us 36 minus 9/4. 36 minus 9 is going to give us 25/4. And well, square root of this thing is going to give us 5/2. Those are both perfect squares, so that's easy. 5/2, and obviously it's centimeters at the end, so always track your units with you, so you can factor out the centimeters squared and take the square root of centimeters squared is just centimeters. Track this unit all the way to the end with you. Meaning overall, this is our height, and thus our area of the triangle is going to be 3/2 times 5/2 centimeters. Okay, don't forget your units, goddamn units. It's going to give you exactly 15/4 squared centimeters. And well, now we are going to get ourselves the surface area, okay? So the surface area is exactly 3 times the area of the rectangle. It's going to give us 54 centimeters squared, plus 2 times the area of the triangle. 2 times 15 over 4 is going to give us 15 over 2. So plus 15 over 2 centimeters squared. And now you can easily add this together basically, giving us overall, okay, we are going to expand this by 2 over 2. 2 times 54 is 108. So 108 plus 15 over 2 square centimeters, giving us 123 over 2 squared centimeters. And if you want to get decimal numbers, it's going to give you 61.5 square centimeters. And this basically concludes this exercise. Pretty easy, am I right? So pretty good. Let us go ahead with the exercise number E here. We have a parabola given, f of x is equal to x minus 1 squared minus 4. And now what are the coordinates of the vertex? Well, good thing is that's a normal parabola. Is it called normal parabola? So with a leading coefficient of 1 here. In vertex form already, meaning we can immediately see what the vertex actually is. So the vertex coordinates are this right here behind the negative sign is always our x coordinate of the vertex, so 1. And what we have here is negative 4, this is the y-intercept. So this is negative 4. And thus we are done with this. And now we are going to draw the graph of f in a coordinate system with an interval from basically negative 2 to 4. Okay, let us see where our vertex lies. Okay, this is the first part. So our vertex lies, this is 1 and negative 4. So here's our vertex basically, and what we also need is the zeros of the function. So the good thing is if you have your parabola ruler with you, like a parabola shaped ruler basically, you can just put it here because it's a normal parabola, okay, just a standard one with leading coefficient of 1. Then you can put it here and just draw it. But the thing is, if you are just like me and you have a blackboard with you in your exams, then you don't have something like this ruler with you, meaning you have to calculate the zeros of this thing, which is actually quite easy. So we are going to set this function equal to 0. 0 is thus x minus 1 squared minus 4. Now we are going to add 4 on both sides obviously, then 4 is nothing but x minus 1 squared. We're going to take the square root on both sides, getting us the two solutions of x. So positive or negative square root of 4 is going to give us plus minus 2, is thus equal to the two solutions, x1, 2 minus 1. And now we are going to add 1 on both sides, leaving us with the first 0 being, okay, positive 2 plus 1 is going to give us 3. And the other solution is going to be x2 is negative 2 plus 1 is going to give us negative 1. And this is good, right? I mean, this is pretty easy now. Here's our 3, okay, first one, and here's negative 1. Okay, and now we can connect points like absolute mad lads, and thus we are done. Okay, great job. This has been the parabola thing, and now what value for the angle gamma satisfies a squared plus b squared minus 2ab cosine of gamma is equal to a squared plus b squared. Now, if you take a good look at this thing, you might notice that on the left hand side we have the law of cosines, and on the right hand side of the equation we have just Papa Pythagoras. Both of those are equal to c squared, but only in one scenario are those two equal, namely in a right triangle, because Papa Pythagoras is just a special case for the law of cosines. Meaning, what you basically want to look for if you would compare coefficients basically is, what you need to notice is that negative 2ab cosine of gamma must be equal to 0. Now you need to find out when is this the case. Okay, if you just take a look, we have a squared plus b squared minus something is equal to a squared plus b squared, then this something must be equal to 0. There's no other way this could be true. So a and b, because those are side lengths in a triangle, are not equal to 0 by definition. Negative 2 is not equal to 0, and the product can only be equal to 0 if one of the factors is equal to 0, meaning we need to ask ourselves the question, when exactly is the cosine of gamma equal to 0? Okay, this happens in a right triangle. Like I said, Papa Pythagoras is a special case, but we can also take a look at the graph of the cosine. Okay, it's exactly 0 at pi over 2. Which is 90 degrees, and this is the solution. this implies that gamma must be equal to pi over 2, or gamma must be equal to 90 degrees, okay, if you want to write it in degrees instead of radians. I'm going to erase everything now from the blackboard, and then for the last 2 exercises. Next up, we be constructing pentagons. That sounds kind of dangerous, not gonna lie. So as for the construction, you can do it pretty easily using just your ruler basically and your geometry triangle ruler thingy. But there's also another way. I'm going to show it to you in a second. So at first we are going to have side lengths of the rectangle parts being 6 centimeters each, okay, given. And then we have that those diagonal lines are going to be 5 centimeters. So on the one hand, you can make use of your ruler in some way. So I don't have a ruler with me, but here's basically, so here's like the 5 centimeter mark. And what you do is, both lines are going to be 5 centimeters each, meaning they are going to meet right in the middle somewhere of this 6 centimeter side length, meaning you're going to mark yourself 3 centimeters, you're going to put a little line here, and then you place your ruler here and just going to rotate it up until you hit like the 5 centimeter mark here. And then you can connect points, or you can make use of your compass. I don't have a compass with me, but compasses are for pussies anyway. Real mathematicians use string and pen. Actually, I don't have a compass. I never had one, but I always have string with me and a pen, because like this you can also construct yourself ellipses. Never mind, so you get yourself the 5 centimeters and you mark it here, and then you get yourself like the markings, just like you would do with the compass. And then you are basically done. And then you can connect points. And thus you are done with this construction exercise. Next up, calculate the value of the angle there. Okay, it's in here, it's alpha. And there are several ways to do this. You can make use of the, so this is 5 centimeters now. I think you can make use of the law of sines. I'm not certain about that. Can you make use of the law of sines? I'm not certain. But what you can certainly do is you can partition this thing up into 2 equally sized triangles. Since this is the middle line, it's going to be alpha over 2 in here as the angle. So this is alpha over 2. Also, that's going to be a right triangle. This side length is obviously 3 centimeters because it's half of this rectangle line segment here, and this is 5 centimeters. And then by just using the sine, you're going to get that the sine of alpha over 2 is opposite over hypotenuse, so 3 over 5, meaning the inverse sine, if we apply it on both sides, of 3 over 5 is going to be alpha over 2, meaning if we multiply both sides by 2, since it's not equal to 0, we are going to get that the angle alpha is nothing but 2 times the inverse sine of 3 over 5, which is something. As a teacher, if you would be my student, if you were my student, then I would love for you to just let it be. Just let it be. Don't write any stupid old angle here. This is good enough. This is a perfectly fine expression. I would love to have this on a piece of paper and not something completely different, like some number. This is more of a number than a number in itself you're going to put me here than the decimal expansion. Alright, just as a side note. Next up, we are going to check if the following statement is true or not. The area of the triangle ABE, meaning this whole triangle here, is half of rectangle BCDE's area. And you can go two routes here. You can use yourself the construction yet again, and if you do like a mirroring image into here, you are going to notice that this triangle isn't going to reach exactly this line segment here, meaning the area of this triangle is going to be smaller than this area. You would have half the area if it would reach up until the line segment there, because then this triangle is equal to this triangle, then this is equal to this, meaning this area is half the area of the whole thing. Okay, but you can also calculate it pretty easily, and this is the route we are going to take. So now we are going to calculate the area of our rectangle at first. The area of the rectangle is going to be 6 times 6, so 36 centimeters squared. And now what's the area of our triangle? Once again, I want you guys to remember, if we had this our triangle with 3 centimeters here and 5 centimeters here, we are going to cut it up in the middle, put it here, meaning we are going to get a rectangle here in a way, where the area of our rectangle is the area of our triangle actually. So this right here is 3/2 times the height in some way. Oh no, this is not 3/2. This whole line segment was 6 centimeters. I'm terribly sorry. Meaning this line segment here is 6/2, which is 3. Okay, 3 times the height is going to be the area of our triangle here. Just a matter of construction in an elementary geometry way. Meaning, area of the triangle is 3 centimeters times the height. And what is the height exactly? Well, the height is this line segment. We can make use of Papa Pythagoras yet again, meaning the height is nothing but the square root of 5 squared, so hypotenuse, minus the other side that is left, 3 squared. So this makes square root of 25 minus 9 is the square root of 16. And the square root of 16, that's yet again perfect square, it's going to be 4. Meaning, that's going to be 4 centimeters. So 3 centimeters times 4 centimeters is going to give us 12 centimeters squared. And 12 centimeters is just 1/3 of 36 centimeters squared. And thus we are done. Doesn't hold. This statement is not true. Next up. Hello kitty catties. Nice to have you. I haven't seen you in a while. Gotta admit that. Plot the profits of the farmers 1, 2 and 3 into a bar chart. What a redundant exercise, seriously. I don't know why this is on the test, but yeah, it just is what it is. We're going to create ourselves a bar chart with the farmers 1, 2 and 3. And now, what are the profits of farmer 1, 2 and 3? Well, we have 60.5, 84.2 and 79.7, meaning we are going to go for a partition of 60, this is 70, 80, and then we have 90 up here. Okay, so 84.2 is right in the middle of those. Okay, that's just a sketch for me. Then 79.7 is nearly 80. And then we have 60.5 is a bit more than 60. Now we can put it into the bar chart. That's the first one, and then we have 84. This goes right up here, and then we have 79 is exactly this. And thus we are done with this exercise. So a bar chart was already part of the part 1 of this exam. So yeah, if you don't know what a bar chart is, then I really can't help you. Then you don't deserve to get any points if you don't even know what a bar chart is. What does the value of cell B4 represent in the context of the exercise? Well, if you take a look at this cell right here, you're going to see that this is just the sum of all the profits divided by the number of farmers, namely 10. And if you sum up all the profits here and divide it by the total number of individuals producing the profits, you are going to get yourself the arithmetic mean. It's not the arithmetic mean, it's the arithmetic mean, alright? So this is just the arithmetic mean, so like the average tons per hectare of profits that the farmers are going to make overall. And now, last part. On average, a sugar beet has a mass of 920 grams. And 19% of sugar, of those 920 grams are some kind of grams of sugar, okay? So 19% of 920 grams are the amount of sugar inside of a sugar beet. Let's put it like this. So 19%, just like the VAT here in Germany, of 920 grams are the grams of sugar inside a sugar beet. I have used Wolfram Alpha before. This is the tool, this is the part, so you're allowed to use calculators. It was something like 174.8 grams are inside of a sugar beet. And now we want to find out how many sugar beets it's going to take us to get 1 kilogram of sugar. And yeah, it's going to be quite easy actually. So if you just think about it logically, 174 is less than 200, and 5 times 200 would give us 1,000. So 5 times, so 5 sugar beets are not going to be corresponding to 1,000 grams of sugar yet. But what about 6, for example? So if we take 6 sugar beets times 174.8 grams, what is this going to be? Well, 6 times 100 is going to be 600. Plus, okay, 70 times 6 is going to give us 420. And thus you're already done, okay? Because 600 plus 420 is already more than 1000 grams. So you're basically done with this exercise at this point, because you need at least 6 sugar beets to get yourself 1 kilogram of sugar. And thus we're done. Thanks for watching. If you enjoyed this video, please like, subscribe, recommend channel. If you want to support channel a bit more, recommend this channel and its content to your fellow students, to your teacher. Maybe he likes what I do here as some kind of online learning process. And other than that, thanks for watching. I wish you guys a fun day. Ciao.